Hi and welcome to this video. In this video I'm actually going to measure the lead in drinking water. So in front of me I have a SenseItAll. So I have a SenseItAll here, just bring that into shot, and I have some lead sensors as well. So I'll just click this lead sensor out and probably put a fresh one on. But yes, just to say I'm going to measure the lead in drinking water. Now I'll just illustrate, or not illustrate, I'll show you where I got the lead from, or the water from. So let me just bring up an image and then I'll share my screen with you. Yeah. Okay, so I'll bring this up. Just want to show you kind of where I got this from. So this is me. You may recognize me there. Just literally grabbing it from an upstairs tap. Now I'm going to be very curious actually, because I might later on go around essentially my house actually gathering water from different taps, because I realised that in a house you can have copper, maybe lead piping. It's unusual, but with that said, we'll find out today. So I'm going to probably later on do a proper survey, but for now I'm just going to measure the lead from an upstairs tap. So this is probably the worst, not the worst, this is the furthest from the mains. Enough chat, let me get into this and do it. So I've got my sample of tap water here. I'm just going to grab 100 microliters of that tap water, which I will do. You will see that this is super quick to do. So 100 like that. The only reason I've got this in shot, by the way, I've got this thing here, is because I actually I can also see, I can bring a microscope in and show you what I'm doing there, but that'll come in a little bit. So what I will now do is grab 100 microliters of the buffer. So a buffer does come with a kit. So here's the buffer. The buffer does come with a kit. You never put the pipettes actually in the buffer, because you could accidentally one day contaminate the entire buffer just by accident. So I've decanted it and now I'll do it. Right, 100 microliters. So I've effectively got a 200 microliter sample, but it's a 50-50 mix between the tap water, which is straight out my own tap, and the buffer. Now I'm going to bring my phone in, and I realize I'm going to have to make Bluetooth connection between my phone and the device. So let me bring my phone in. The next thing I have to do is log into the app, which I will do. As you can see, I'm essentially doing this all live because I'm logging in and doing things in real time. Now what I'm going to do is I'm just going to scan a QR code, because if by scanning a QR code now, I've come into, the app is set up now to do copper and lead. So I'm actually, when I say I'm going to detect lead, I actually should sort of be a bit more clear and actually say I'm also going to do copper at the same time. I'm just going to tell the app where to save the data, which I will do. Tap water upstairs. This can be quite useful later on when you're trying to, essentially find it. Now this is, I just put the word in one. This is just me so I can find it later on. 121. I know that just means I'm sort of did a 1 to 2 dilution. What I want to do is I've got all that set up now, so I can put that app down. I've got my sample here, and what I'll do now is I'll get a 50 microliter pipette, and I'm just going to put 50 microliters onto the sensor. Now taking the water literally a few seconds, preparing that sample, 30 seconds. And now what I'll do is I will put the sample on like that, which I have done. I didn't connect the device, so I must just do that real quickly. So I'm just going to connect it. There we go, connected. Right, so that's now connected. I can go continue, and I must remember this was a 1:2 dilution I did. So I've got a 1:2 dilution, start measurement, and off it goes. Now what I'll probably do is actually end up fast forwarding this, because it could otherwise get extremely boring. But at the moment I don't want to say it's a two-step process. You won't notice it's a two-step process, but it's doing something where it's essentially enriching the lead onto the sensor, or I should say lead and copper onto the sensor, and then it will actually measure those things. The measurement is quite quick. The enrichment is not so much, I don't want to say, if I say slower, it sounds controversial, but I mean, don't forget, the alternative way of doing this is actually to take a sample. Probably have to fill out quite a bit of documentation so that you can trace the sample. That sample then has to go to a centralized laboratory. There they may use a piece of equipment called an ICP-MS. I want to say it's inductive coupling plasma mass spectroscopy, but I've got to be a little bit careful with that term. I've got to look it back up again and remind myself my analytical chemistry days and remind myself what actually instrument that really is. But it's quite a burden to actually take a sample, essentially prepare it, or send it off to a centralized laboratory. Eventually it will get tested, and then you've got to kind of find that result, and you've got to sort of pair it back with the original sample. It can get administratively a little bit messy, but the nice thing about this is you can take the sample yourself, so you've got full custodianship on it. It's simple enough to have prepared that sample, and just to speed things up a bit, I used a 100 microliter pipette and I used a 50 microliter pipette. As you saw, I just drew 1 volume of the water plus 1 volume of the actual buffer. I just shook that up. I then forgot that I hadn't set up the app, so I quickly set up the app. And the app is quite clever because it not only it tells the instrument what to do, the instrument does it, but the app is also a conduit for the cloud. So when the data comes back, it will actually end up going to a cloud system called Julie. And I'll share that with you as well, because then it kind of means that somebody can be, remotely doing a survey, gather a whole bunch of samples. They don't even have to write it down. They can actually just, they can put it in the file name, upstairs bedroom, or, tap by shipping door and all sorts of stuff. Give them some names, and then it will actually end up. You can use the naming there to trace the sample back later on. So it really reduces the kind of paperwork and the administration of trying to do these essentially tap tests, because the person's there, they know what they're doing, they can make a name that's sort of representative. You can essentially invent a naming convention that kind of helps the organization. I must say that we're not necessarily intending for home users to necessarily use this kit. I mean, they're welcome to, but at least the way it's the way we consider it at the moment, this is for kind of professional use, and saves the whole effort of you send somebody out, all they're really doing is collecting the sample. The sample has to kind of come back into the centralized laboratory. It probably has to be prepared in some way. It then has to go into a carousel. It then has to get run. You have to then tie that actual result directly back with that sample. When you've got hundreds of samples, or maybe even thousands, that can become really quite a pain. I mean, admittedly, people have electronic electronic records, LIMS, laboratory information management systems. I should say that this also has an API built into it, so an application program interface. So a lot of LIMS systems are looking for API, so effectively you can plug the data in. Now it's actually doing the analysis, and this is quite clever. So anything that's so far been done, including that sort of pre-enrichment step, including the analysis step, all of it gets saved. You'll find out that in fact it's got the so I've got my lead and my copper. It says low on both of these, which probably means it's sort of below the kind of the regulatory requirements. There'll be regulatory requirements that kind of say you shouldn't be above this and you shouldn't be above that. But now we can actually go in and have a quick now we can go in and have a quick look at the data. So let me just go to here, and so we have a system called Julie. I can see my instrument here. I can click in tap water. Bad spelling, my apologies for that. I was just typing quite quickly, but I do actually have my data saved to the cloud, so I get kind of full custodianship on this. So I can really see what's kind of going on, and I can see that we've picked up the lead peak, and I can also see that we've actually picked up the copper peak as well. So the now it said low on both of them because we don't want to kind of have to necessarily report something that's already below the regulatory cutoff. But here I can see that we've got about 4. It's 3.8. Just out of interest, there's sort of in some parts of the US the legal sort of cutoff is actually 4 ppb. So you know, I may personally actually have to think about a filter on this on our drinking water. And I can also see that we've also got copper as well, which is about 200 ppb. They set the legal requirements for copper higher. So yeah, there's, you know, essentially 2 orders of magnitude difference between copper and lead. But yeah, I mean, we can definitely see both in that sample. I do have, you know, I know the name of it. I know the time. I know the date. I know who did it. And I can see all the raw signal. I get the result. I get the raw signal. So there's a really good format for traceability built into this system. And I can also, if I so wish, save this elsewhere. So I can export it as a PDF and grab the data elsewhere on my not on my computer, but I can save it elsewhere as well. So I'll just open up that, and I can put that up onto a server, and you can have basically a full record of the test. So that's essentially sort of part of the quality system that you also get that as well. So if I was to summarize it, then I've got in front of me, I've got the SenseItAll from Zimmer and Peacock. I used the QR code to go into the lead mode. I put a lead sensor on there. I took water from my own house. I took buffer from, I took the buffer that comes with the system. You can see I only needed sort of 100 microliters of buffer in this particular case. And there's something like, I want to say there's about 250 mils in here. I don't want to, yeah, about 250 mils. So I can run thousands of samples theoretically with that. You do get a nice, easy result on the phone. But you also get a more, it immediately says on the phone, upload complete. And you can also see on the phone as well, sorry, not on the phone, but you can also see that we can also go up to the cloud and actually gather that, look at that data and make a more sort of critical view on it and export it as a PDF as well. If you have any questions, don't hesitate to reach out to us. Okay, thanks very much.